Welcome to Ask and Learn.
Hi everyone, Tim Johns here, and we're dealing with another problem dealing with displacement, velocity, and acceleration. So the deal here is we're dealing with an exponential decay function, which is going to be a tiny bit different than what we've been dealing with so far. So we're given s is equal to minus 2 plus 3t, and all of that's multiplied by e to the minus 0.5 times t. So we need to plot all three of these. First things first, whenever t is 0, our position right here will start at minus 2. And if we plot this acceleration function using a graphing calculator or a graphing software, this is kind of the shape that we'll see right here. And as t goes to infinity, the exponential function will approach 0 as close as it can, but it will never quite reach 0. All right, next thing is we're looking at the velocity, which is just the derivative of the position function. And we'll be using the product rule here to take this derivative. So first things first, minus 2 times e to the minus 0.5t is just minus 2 times the constant in front of t, and then times the exponential function again. And now we're using the product rule. We have 3t e to the minus 0.5t. So first what you do is you take the derivative of the term on the left side, which is just 3, and then we multiply it by the term on the right side. And then we're multiplying the term on the right side and keeping the left side. So plus 3t, the derivative of e to the minus 0.5t is just minus 0.5, and e to the minus 0.5t. And to simplify this a little bit, the first term of our velocity is positive e to the minus 0.5t, so we can go ahead and add that to 3 e to the minus 0.5t, and then we'll just have 4 times e to the minus 0.5t. And if we evaluate the final term, we have minus 3/2, and all of this right here is being minus 3/2 t, and all of this is being multiplied by e to the minus 0.5t right here. Let's go ahead and mark our axes as well. So s is in meters, t is in seconds. And here velocity is in meters per second and time is in seconds. So whenever t is 0, our velocity is starting at 4 meters per second. And we can go ahead and do the same thing we did before, graphing this on a graphing calculator or graphing software. And we'll go ahead and see that this is what our exponential function will look like. And it will not reach 0 again, just like exponential functions do. It will approach 0 as t goes to infinity. All right, and the last thing here for the first three things is the acceleration. So the acceleration is the derivative of the velocity with respect to time. And we're kind of doing something similar we did before. So we have 4 e to the minus 0.5t. That is just 4 times minus 0.5 e to the minus 0.5t. And then we're using the product rule again. We have minus 3/2 t, or t times e to the minus 0.5t. And to make that simpler, take the derivative on the left side to keep the right side, and do the same on the right side. So we keep the left side and take the derivative of the right side. So minus 3/2 t times minus 0.5 e to the minus 0.5t. All right, so first term evaluates to minus 0.5 times 4, which is minus 2. So we have a minus 2 minus 3/2, which is just minus 7/2. And then we have on the left side, we have minus 3/2 t times minus 0.5. This will just evaluate out to positive 3/4 t. All of this is being multiplied by e to the minus 0.5t. Or if we're just keeping this consistent, we'll just keep everything in fractions. So it's the same thing as minus t divided by 2. And finally, the last part of the problem will ask us, what is the time when the acceleration is 0? So we need to set our acceleration here to 0. And we'll get we'll get two little equations here. We'll have minus 7/2 plus 3/4 t is 0. And then we'll have e to the minus t divided by 2 is equal to 0. So if we try to solve the right-hand side, take the natural log on both sides. Natural log of e is just 1, and then the minus t over 2 comes out. And then we'll have the natural log of 0 on the right side. So the natural log of 0 is undefined, which is basically saying on our acceleration plot that the next 0 here, the next 0 is undefined. So the t in seconds, acceleration in meters per second squared. So basically our acceleration function is going to approach 0 but never quite reach it. So the next 0 is undefined. And also plotting the acceleration plot here, we'll have kind of something that looks like this. And this first 0 is actually what we're solving for right here. Whenever t is 0, we'll have minus 7/2. And next we're going to solve for that last 0 here. So all we need to do is solve this equation on the left side to solve for t. And in doing so, we'll get that t is 14/3 seconds.